Yours going.
All right. Yeah, turn mine off too.
All right. Hello, everyone. Welcome to the 2018 Voices Conference. This is our 6th annual event, and we're really excited to have you here or watching our recording. So this is session number 2, which is the intersection of computer vision and machine learning by Kesha Williams, who is at Chick-fil-A. So Kesha, I'm going to hand it over to you in just a second. A couple of things. One, there's a chat window at the bottom of the screen. I'll enable that now. And if you want to introduce yourself or let people know where you're from, or if you have any questions for Kesha, we'll be answering those at the end of her session. So with that, I'm going to turn it over. Here you go, Kesha.
Hello, everyone. I am so happy to be here with you, sharing with you about the intersection of computer vision and machine learning. So I'd like to start off by saying that Minority Report is real. Pre-crime is real. After watching a science fiction movie, I'm often left with the thought, now, did the movie inspire the technology, or did the technology inspire the movie? So I have a case to share with you today where the movie actually inspired a practical use of the technology. So I'd like to show you a quick clip from this movie.
Homicide, 1 male, 1 female. Killer's male, white, 40s. Set up a perimeter and tell on risk. Listen, you under arrest for the future murder of Sarah Marks. Give the man a sound. Future can be seen. All we have to run on the images they produce. We see what they see. There's been murdered in 6 years. There's nothing wrong with the system. It is perfect. I agree. Can be stopped. Exactly what it is here. Flaws. You ever get any false positives? We are arresting individuals who've broken the law, but they will. The fact you prevented from happening doesn't change the fact that it was going to happen. The system can't be wrong. You said something to me? No, you're in a lot of trouble, John. I have a warrant in my pocket that says murder. Don't run. You're gonna have to change me from the 20th Century Fox. He set me up. He set me up. And DreamWorks picture this. I've never heard of them, but I'm supposed to kill them in less than 36 hours. He's coming here to get us. Tom Cruise. I need your help. Keep the information. I need to know how to do that. From a Steven Spielberg film, I have to know. I have to find out what happened in my life. You tell me, who was it who set this up? I don't know. How about now? June 21st. Everybody.
So that was a clip from Minority Report, and that movie is the inspiration for what we're going to talk about today. This is one of my favorite movies. I've seen it a million times. So for those of you who haven't seen it, this movie came out way back in 2002, and it's set in 2054, and it introduces this concept of pre-crime. So that's where criminals are arrested right before they commit the crime. Now, in that movie, they use psychic technology, but fast forward to 2018, we will use another technology. So in Minority Report, there is the concept of pre-crime. Pre-crime is just like foreknowledge. So this is where criminals are arrested before they commit the crime. Today, foreknowledge is considered machine learning. So this talk, we are going to talk about pre-crime. What does it look like in 2018? We'll talk about machine learning, and we'll also talk about computer vision, just overall concepts. We'll talk about Amazon machine learning and their recognition service. And if we have time, we'll talk about IoT as well. I will introduce a really cool case study. We'll talk about the social implications of computing, and then we'll have time for a Q&A. So before I jump in with machine learning, let me tell you a little bit about myself. So my name is Kesha Williams. I've been in IT for about 23 years now, and I definitely have the gray hairs to prove it. I've worked at a lot of fun places. I currently call the IT department of Chick-fil-A home. And so I have two main roles at Chick-fil-A. I am a full stack web developer using Java and Spring and Angular. And then the second part of my role, which is really the fun part of my role, I am allowed to lead innovation teams as we research emerging technologies like machine learning and computer vision, IoT, and all of those cool things. I've also worked at Delta doing web development with the US Air Force, and eyes always narrow in on the National Security Agency when I show this slide. Now, there are a lot of fun stories I could tell about the NSA, but if I told you, I have to hunt you down and kill you. So I can see everybody's name on here I'd have to hunt down if I told you anything about the NSA. So let's talk about machine learning. So machine learning is a subfield of computer science that was coined by Arthur Samuel way back in 1959. And basically, it gives computers the ability to learn without being explicitly programmed. But what does that mean in layman's terms? So in layman's terms, a machine learning program is one that answers questions based on its study and analysis of past data. So you can think about it like this. A computer finds patterns in past data so that it can make predictions about the future. So we've all heard the phrase that past performance is a good indicator of future performance, and that's really at the heart of machine learning. Now, machine learning is used all over the place. I was actually surprised when I learned about all of the different use cases of machine learning. So did you guys know that machine learning is used in the loan approval process? So there may be a computer program that says either yes or no when you apply for that home loan or for that car loan. It's also used in employee hiring. So there could be a machine learning algorithm that decides on whether or not you'd be a good fit for the company that you're trying to work at. It's also used in healthcare. So this, for me, is just super cool because there are some machine learning programs that are very accurate at predicting certain forms of cancer long before a diagnosis. So that's actually life-saving. It's also used in personalized marketing, recommendation engines. Like I have Netflix, and every time I log in, they are always recommending a new movie or a new TV show that they think I may like. There's a machine learning program behind that recommendation. It's also used to combat financial crime. So machine learning algorithms, it's called anomaly detection. They can look at certain transactions and just notice that something is a bit off when that transaction is compared to past transactions. So it's used for financial purposes. It's also used with law enforcement and in the courthouse. Now, I was totally shocked when I learned that in the courthouse, there are some judges that use machine learning programs to predict whether or not someone will be a repeat offender. And then, so that prediction or that response from the machine learning algorithm helps the judge make their ruling. So there's a person that may not get parole if the machine learning program says they'll be a repeat offender. So when I was learning about machine learning, I often confused it with business intelligence. So I just want to talk through what machine learning is not. So business intelligence is really a way to visualize data. So when you think about charts and graphs, that's business intelligence. And it allows a human to make a decision based on the data. And so business intelligence can answer questions like, what percentage of crime in the state of Georgia happens in Cobb County? Or calculate the number of vehicle thefts versus assaults. That would be business intelligence. Now, machine learning can answer questions like, what's the likelihood of a crime occurring in this county at this time of day, given these circumstances. So that's machine learning. I also mentioned computer vision. So computer vision is a field of AI, or artificial intelligence, and computer science that gives computers a visual understanding of the world. So what does that really mean? Computer vision allows a computer to look at images, photos, videos, and identify people, places, things, and really extract information and attributes from the image. So a computer can actually see what's going on. Computer vision is used all over the place as well. It's used in the airline industry. I read an article the other day about Delta Airlines piloting a facial recognition system for bag drop. So now you just drop off your bag and you check in with your face. It's also used in casinos. So if you happen to be on the banned list or the naughty list for a casino and you walk in, they have facial recognition systems that will automatically identify you and alert security that you don't need to be there. So casinos make use of computer vision and facial recognition. MasterCard also they have what they call selfie pay. So it's basically where you pay for transactions using your face. I think that's super cool. And then hotels, there are some hotel chains that actually use it. So when a VIP customer walks in, they receive special treatment. And it's used all over social media. So anytime you guys upload photos to Facebook and you see it's automatically tagging people, that is computer vision and facial recognition. So what happens when you combine machine learning and computer vision? I bet you'd like to know, but before I tell you, let's look more closely at pre-crime in 2018. That's something I said we talk about. So in 2018, in today's world, pre-crime is called predictive policing. I'm not sure how many of you out there have heard this term, but predictive policing uses predictive analytics, that's machine learning, to determine the likelihood of crime. And it's called an innovation that's capable of stopping crime before it starts. Now, I don't know about you guys, but for me, that sounds exactly like pre-crime. There was even an article published by researchers at Stanford University, and it's called Artificial Intelligence and Life in 2030. And in that article, they made claims that predictive policing will be heavily relied upon in the next 15 years. And so I don't know if we'll ever get to the extent of what's shown in Minority Report, but we're definitely headed that way. So predictive policing in real life. There are a lot of instances where machine learning is used in policing. So in this image, this is from Pittsburgh, Pennsylvania. Police officers actually ride around in their patrol car with a laptop. And so this laptop is running machine learning algorithms, basically identifying hotspots in the city where crime is highly likely to occur. And so that's the area where the police officers patrol. And just the thought of just having heightened police presence, they are thinking that it will reduce crime. And so I thought that was really cool when I heard about what Pittsburgh was doing. It's also been tested in Chicago. So the Chicago Police Department, they create hotspot maps. It's also been tested in the UK. The Department of Homeland Security has this system called FAST, and it has a 70% accuracy rate at predicting the probability that a passenger is planning to commit a crime. And so I always say, well, if you have FAST, why do you always make me go through security and take off my shoes and take off my coat and all of that? Just run this on me and you'll see I don't have intentions to commit a crime. So we could all move through security faster. So now let's get back to talking about what happens when you combine machine learning and computer vision. And so I'd like to introduce you to our case study for today, and his name is Sam. So don't laugh at me. I always name all of my AI programs that I create. And so like me, I call Alexa she or her, not it, and I get teased all the time. But this is Sam. Sam stands for Suspicious Activity Monitor, and he is a machine learning algorithm that I created that also uses computer vision to predict the likelihood of crime given a certain set of circumstances. And so anyone can talk to Sam via Twitter. So let's say you're walking down the street and you see someone you think is involved in suspicious activity. So you take a picture and you tweet it to Sam. And then Sam he pulls the photo from the tweet using the Twitter API, and then he uses computer vision to analyze that photo. And so what he'll do, he'll pull out attributes about the person in that photo, like age, gender. He'll get some additional information from the tweet, like location, time of day. And all of that data he then sends to his machine learning brain that makes a prediction on whether or not a crime is about to occur. And the response goes back to the user as a tweet. And so the user will get a message like, oh, you need to run for your life, or you're safe, there's no evidence of a crime being committed. And so Sam is really just a fun case study that I created to prove out machine learning, more specifically Amazon machine learning, and computer vision and the Amazon recognition service. And so later on, we'll crack open the code for Sam. I'll show you guys the architecture diagram of all of his different parts and pieces and how everything fits together. So let's have a quick demo of Sam. So you guys can see I like reggae. My husband is a reggae musician. So let's say you're on Twitter and you want to send Sam a picture of someone you think is involved in suspicious activity. You will tweet him that picture. And now at this point, his back-end machine learning algorithm, computer vision process is pulling that picture, pulling the attributes, and in a moment we should see a notification, a Twitter notification appear with his response. There we have it. It's one response. And so his politically correct answer is, I see several factors that indicate the likelihood of crime. So that is Sam. So this is his architecture diagram. And if you notice, his entire ecosystem really runs on Amazon Web Services. And so for the first half of this talk, we're going to focus specifically on the machine learning portion. And then for the second half, we'll look at AWS recognition. But here we have the user here. The user sends a tweet and it's stored in the Twitter database. And then we have this Lambda here. And just to explain what a Lambda is, it's just a chunk of code or a function that runs in the cloud that's like an API. And so we have the Lambda here. It retrieves the data from the Twitter database, which is the photo. And then it sends that photo to AWS recognition here. And the attributes come back to the Lambda, and the Lambda then sends those attributes to the machine learning brain. And so here we have a machine learning algorithm that really gets its data from computer vision or the AWS recognition. And so then a prediction is made, and that prediction is sent back through the Lambda to the user. So at a very high level, that's the architecture of SAM. So now let's really dig in on machine learning and how does it really work. So there are 3 types of questions that a machine can answer. And so these are called classification problems. And so the first type is binary. And a sample question is, will this person be a repeat offender or not? So when we talk about a binary type question, it's a yes or no answer. There's also the multi-class. So this is where the machine is coming up with an answer that's one of many. So for example, in this case, a question could be, is this item a toy, movie, or a book? And the machine can answer that type of question. There's also a regression problem, and that's where you're trying to determine a numeric answer. So for example, regression would say, what will the temperature be in Atlanta tomorrow? So those are the types of questions the machine can answer. Now, how do machines learn? So that's the next question. There are 3 ways that machines learn. Remember, I said that machine learning teaches computers how to make predictions from historical data. And so we have to give the machine the data. And so with supervised learning, this is where you give the machine data with that already has the answer that you're trying to predict. So the machine goes through and studies that data to find patterns. And so that's supervised learning. There's also unsupervised learning. And honestly, this is the one that really causes the most buzz when people talk about machine learning, because in this case, we're not really giving them labeled data. So the data doesn't have the answer that they learned from. So the machine just really goes in blind and looks at the data, and it tries to find answers, tries to find patterns, and it really comes up with whatever it comes up with on its own. So that's the one that's really cool and causes the most buzz. And then there's what's called reinforcement learning, and that falls somewhere in the middle of supervised and unsupervised learning. So there's some feedback that's given at each step. And we see reinforcement learning a lot with robotics. And so imagine a robot that's moving through a maze. The first time it goes through that maze, it may bump into a wall. But the next time it goes through, it knows that the wall is there because it has that feedback. And so the next time it doesn't bump into a wall. And so that's reinforcement learning. Now, Sam, the example that I'm going to show you today, is supervised learning. And so I taught him with data that was labeled with the actual answer to the question I was trying to predict. And that question is this crime or not? So there are really 3 steps in the data science process. So the first step is to get your data, and then prepare your data, and then load your data to a place where the machine learning program can actually get to the data. And then we go through what's called the training process. So this is where we actually teach the machine learning algorithm about the data. And then the third step is to actually use the machine learning algorithm to generate predictions. So now let's jump in and actually look at how we do this using Amazon machine learning. And I tell you, Amazon makes it so easy. So I am, like I said earlier, my day job, I'm a Java developer. I'm not a data scientist, but I wanted to learn more about machine learning and the Amazon way of doing machine learning. And so I spent 1 week, spring break, and I was able to create SAM from front to back, start to finish. And so Amazon really makes it easy. So let's look at that process. So first, we're going to look at the back end. So if you remember from the architecture diagram, I put that circle around the machine learning box. So that's the process that we're going to look at now. So first, we're going to look at how to obtain the data. Then we'll go through and explore and understanding the data. And then we'll prepare the data, train the model. And so remember that word model. The model is, it's really the brain, the machine learning brain, and I'll talk more about that later. And then once you have the model, you have to evaluate how well it's performing and optimize it. and then you test it, and then you enable it so that you can actually use it in a real application. So the first step that I went through to obtain crime data, I went to the GBI, the Georgia Bureau of Investigation, and they actually have data that's downloadable. And so I can download historical crime data for the state of Georgia. And it's not just the GBI, there's also downloadable data on the Atlanta PD website. So I was actually surprised to be able to get this data, but it's there. Whatever state you live in, I'm sure there's a website where you can pull down the crime records if you wanted to build your own version of SAM. And so what I did through their website, I downloaded several different files. And then I had to go through the process of really cleaning up the data, merging the data, and so that I could actually load it to Amazon. So after I downloaded the multiple files, cleaned it up, merged it, I loaded it to Amazon, initially using a tool they have called QuickSight. So QuickSight it's business intelligence, it's BI. And so I just really wanted to understand more about crime. Like, what does crime really look like in Georgia? And so it's very important when you build a machine learning model to actually understand the data that you're using and that you're training the machine on. The better that you understand it, you'll be able to spot anomalies or things that are incorrect. And so I went through the process of loading the data to QuickSight, and I created several charts and graphs just so that I could understand what does crime really look like in Georgia. And when we look at this graph, I feel like now I'm an expert, a crime expert about the state of Georgia. But this is one sample graph that I created, and it shows the crime broken down by county. So here on this far left, there's Fulton County. So if you ever come to Georgia, stay away from Fulton County. You can come visit me over here in Fayette County. And it looks like Fayette County has the least amount of crime in Georgia. So I am glad that I picked Fayette County. It's a great place to raise a family. And so once I understood the data, I went through and I prepared it. And so this is just a screenshot of the data that SAM was trained on. And so when you're preparing your data, there are really two elements. The first, they call it a variable or a feature. And it's like, what are the attributes that can be used to identify patterns in order to make predictions? And so in this case, I'm using county and state, that's the location. From the tweet, I'm pulling time of day. Using the computer vision, I'm pulling the gender of the person in the photo, the age of the person in the photo, and then also from the tweet, day of week and month. And so if you notice, the second most important part, they call the target. So this is the actual answer that you want to predict. So here, when I train Sam, he sees positive crime records and negative crime records. And so now the positive crime records, that's what I pulled from the GBI. The negative crime records I had to create myself, just so that the spreadsheet would be balanced. In a real world scenario, for example, if I worked with the Atlanta Police Department, I would pull both positive and negative records from their data set. So for example, conviction versus arrest. And so here, whenever you're training a machine learning program using supervised learning with the binary classification, you have to feed in the labeled data that shows positive and negative. So once I had the spreadsheet, I loaded it to Amazon to an S3 bucket. So an S3 bucket, it's nothing more than a file storage system in the cloud. And so I loaded the file, and that's the file there, the SAM crime training data set. And so now the data is in the cloud, and I can actually use it to build a machine learning model. And so after I loaded it, my next step was to launch the Amazon machine learning service. And now this is a general purpose machine learning service. And like I said before, it makes it very easy for everyday developers like myself to build complex machine learning programs. And it's really cool because it's like a visual interface, drag and drop, and it really abstracts away a lot of the complexities around building machine learning algorithms. So it's really cool. You guys should check it out. Now, I mentioned the term model to you before, and I said that's like the brain of the machine learning program. And so the model is really the most important piece because it's the piece that returns predictions. So you send in a question to the model and you get an answer or prediction back. So what are the steps to create the model? So first, you create a data source, what's called a data source, and then you go through that training process. And so let's look at that. So in order to create a data source, you'll have a screen that looks like this, and you have to actually point to where you loaded that spreadsheet on the Amazon S3 bucket. And so really that's all a data source is. It's a pointer to your training data. And so here you see I selected S3 because that's where my file is loaded. So once you set up the data source, it's really just a click of a button to create this machine learning model. And so here, you just click Create, Train, an ML Model, and Amazon, it's like magic, Amazon does the rest for you. And so based on the data that you load up, Amazon picks the different learning algorithms and all of that behind the scene, and I'll talk more about that later. So really, like I said, a click of a button to create this machine learning model. And then this page talks about the model settings. And so this is where you set up how the training is going to work. And so the training process at a very high level, it's where the algorithm goes through and it makes passes over the data trying to find patterns. And so during training, there is a common strategy to use 70% of the data that was in my spreadsheet, use 70% of that as training and learning and using it to find patterns. And then the remaining 30% is used for testing and evaluation. So the model learns from the first 70%, and then it evaluates internally how well it's doing at making predictions by testing itself using the last 30%. Now, if you see here, there's a custom option too, where you can change that 70-30 split to something else, but typically it's 70% for training and 30% for testing. So I mentioned to you the training process. So this is how the model is created. And this is where all of the patterns that are found, they're stored in the model. And so under the covers with training, there's a learning algorithm. And so the learning algorithm consists of a loss function and an optimization technique. And so the loss function is really the penalty for when the model guesses incorrectly. And the optimization technique seeks to minimize loss. And the whole process, there's the SGD stands for stochastic gradient descent, but just in your mind, think of that as making like sequential passes over the training data. And just during each pass, it updates just how well it's doing until it comes to this optimal model that doesn't really make a whole lot of mistakes. And so that is the training process. And so the learning algorithm, it's automatically picked for you behind the scenes for Amazon machine learning. You don't have the option to change it or pick your own. And just for you to know, for SAM, because it's supervised learning and it's a binary question, behind the scenes, it uses linear regression. So that's the learning algorithm that it uses. So once the model is actually created, it's very important for you to understand how well that model is behaving. How good is it at making a prediction? And so the model has a score, and it's called the quality score. And so that quality score is called AUC, or the area under the curve. So just know that all machine learning programs have a score. And in this case, the range is from 0 to 1. And Sam's score right now is 0.897, which is very good. So Sam is good at predicting the likelihood of crime. And so when we talk about the AUC, how does Amazon come up with a score? So all predictions by the model are reviewed, and then it counts how many times 4 particular outcomes occur, and it visually charts it. So when we think about the outcomes for a machine learning model, one would be a true negative. So this is where Sam predicts 0 or no crime, and that prediction is correct. There's the false negative. So that's where Sam predicts a 0, no crime, but he should have predicted a 1. And so here he's failed to predict crime accurately. Then there's the false positive, and that's where Sam predicts crime, but there's really no crime. So he's considered a harmless person to be a criminal. And then there's the true positive. So that's where Sam predicts 1, and he should have predicted 1. And so really you can go in and adjust your tolerance level for false positives and false negatives. And so it really depends on the criticality of the answer or the question you're trying to answer on your tolerance level. But just know Amazon makes it very easy for you to adjust that tolerance level. And then that's basically it. You have a model that you can make available through an API endpoint, and you can use it for real-time predictions. And that's how Sam works. He uses a real-time API. There's also the option to use batch predictions, but that doesn't work as well for crime because people need to know pretty quickly what's going on. And so for the front end of Sam, if you remember from the diagram, the Lambda and the AWS recognition. So AWS recognition, like I mentioned before, and that recognition is spelled correctly, it's with a K instead of a C. It makes it very easy to add image analysis to your applications. And so remember with Sam, he gets his data through Amazon recognition. So let's look at some code. So here, the front end of Sam is actually Python code, and it's a Lambda. And remember I said a Lambda is just like a function that runs in the cloud. So here I'm using the Boto3 library to actually create a recognition object. And so here I have the recognition object, and then I also have here the machine learning object. And so in this code, I'm actually getting the image from the tweet, and then I'm calling detect faces and detect labels. So those are functions within the computer vision library that return attributes about a person, like whether or not they're happy, they're sad, how old they are, what gender they are. And if you look here, I'm testing to see if the person is happy and it's making an assumption that happy people don't commit crime. And so only if the person is not happy does the process continue. And so here I get the age from the person using the average age. And then I'm getting the gender. And then I'm getting additional information from the tweet, month, time of day, day of week. And then I'm sending all of that to this model. And I'll post these slides so that you guys can have all of this code to look at and play around with. And so here, once I call the model, I'm getting back a prediction, and that's that 0 or 1. And so here, if there's no crime, I use the Twitter API to send back a tweet to say, I see no factors that indicate the likelihood of crime, or I see several factors that indicate the likelihood of crime. So a few things to note when it comes to using Amazon and machine learning. The data must reside in S3 in order for you to use the machine learning service. Models that you create can't be exported, but they can be exposed through that API. Amazon Machine Learning doesn't support complex problems like recommendations or anything related to unsupervised learning. Now let's see, given where we are with time, I don't have a lot of time to go into the IoT, but that's just, for me, it's like a magic button, and you can click it and it kicks off AWS services. And so I have this IoT button that when I click it, it kicks off SAM's Lambda, and so it kicks off the whole process. Let's see, we have about 5 minutes left. I do want to have time for questions. I do want to note, though, before I turn it over for questions, when you're building a machine learning program, you as the developer, you really have a moral and ethical obligation to make sure that what you build doesn't destroy someone's life. And so machine bias, this is where a computer takes on the bias of its creator. It's a big problem nowadays with machine learning algorithms. So let's say when I created SAM as the developer, I included race. That could lead to racial profiling. And so I purposely excluded race as one of those attributes that SAM uses to make a crime prediction. And so I just say, as developers, Amazon gives us very powerful tools. They give us tools that can really affect someone's life. And so it's just very important to make sure that whatever we build, we try to make it bias-free. So that's very important. Let's see. So just the future of machine learning. Machine learning is really the next wave of transformative technology. I'm just very excited about where we're headed. And, you know, Google made this comment that they are no longer a mobile-first company, that they are an AI-first company. So that just really speaks to the importance of AI and machine learning and computer vision, and really where we are headed in the future. So let's see. SAM 2.0, a few just future enhancements that I have for SAM. But before I turn it over for questions, this is important. And so I know I've covered a lot in only a little bit of time. And so everything that I've said, all of the code, all of the training spreadsheets and files I've documented here at this link as a training course. And I typically charge for it, but for today and probably, well, I guess through until the end of the Voices conference, maybe Saturday, I'll turn it back to costing money. But for right now, it's free. So I would recommend that you guys sign up for that course, and it just goes into more detail about everything that I've covered today. And so we have 2 odd minutes left for questions. Deanna, do we have any questions? Let's see. I don't know how to get to the questions to see. Let's see. Stop sharing. Okay.
Sorry about that. I was having a problem getting online. So if you go down to the chat window,
Yeah.
there's a question there about fails. Let's see.
Sales, let's see.
Yeah, I don't, it says, I don't understand. Runa, I don't understand your question.
Am I audible?
Oh, yes, you are. Hi.
Okay. So my question was that machine learning algo, when you said that it fails to predict, is it because of data or is it because of algo?
I said that it failed to, what did it fail to predict? I'm trying to remember.
When we said that sometimes it fails to predict and after that it goes to the learning module, right? So when it fails to predict something correctly, so is it because our data was not correct or there was a shortcoming in the algo?
Okay, so yeah, it's usually a data issue. So for example,
Right.
with Sam,
We have one, Davina. Yeah.
with Sam, there are like 5 or 6 or 7 attributes like age, gender, time of day. If I leave out any of those like required attributes, it definitely reduces his ability to make an accurate prediction. So I hope that answers your question.
Yeah, thank you. Just one more question, that when it failed and you said that data was not correct, so during that learning phase, it will go and update the data?
Oh, okay, about the learning process. Okay, so no, what it does, when it guesses incorrectly, I think that's what your question is related.
Right.
When it guesses incorrectly, it goes back over the data again, and it keeps going through this process of learning and trying to find patterns and adding new patterns until it no longer guesses incorrectly.
Okay, okay. Thank you so much.
My pleasure. Any other questions? Okay. I think that's it. Well, thank you guys. I really enjoyed sharing with you about SAM, and I recommend that you sign up to that course and just go through it in more detail and play around with it. It's a lot of fun.
Thank you so much for what a great session. We really appreciate the time that you took, and we'll have the recording up shortly.
My pleasure. You guys have a great day. See you later.